Welcome to Turn Right Machine Works. I've got this 1/2 inch stainless steel plate on here, and we've got 3 large plates that we have to cut out. And each plate has got 4 oblong holes or slots that I got to be put into them. Now, we may be able to pierce 1/2 inch stainless steel one time. I don't know how much of a repetitive piercing that we can get away with, and how much blowback we get and all that. So what we're doing now is we're hitting each one of our pierce points, and I'm marking it, and then I'm going to get up on the table and I'm going to go ahead and poke a drilled hole in each and every one of those spots so that I have the ease of coming in and then just starting my cut. And that's what I'm up to right now. So I'm just kind of locating my individual holes here. That's the last one right there. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 5, 5, 5. Alright, and this diameter here is a 5/8 transfer punch adapter here, and all we got to do is basically get it in the center here of each one of our little circles. Alright, we're going to go get our shop vac. Alright, we changed up from that cobalt bit. Not that it wasn't doing anything, it just it felt like it wasn't doing anything. This bit here, about the same thing. You know, the finished product is well worth the extra effort on drilling the pierce holes. If it's questionable, you know. Yeah, a couple more to go. Okay, there's all of them, which is make sure we got 4, 5, 4, 5, 4, 5. All right, that's 3 plates with 12 slots total, and let's go ahead and let her cycle through and make sure that we're still on the top of all of those. I really I can't see us moving that plate around. It definitely doesn't feel like it's lacking contact there. Okay, let's highlight this group and go. Alright, we're going to go ahead and change that now. At first we were going to attempt to pierce them, and of course if we were going to do that we wanted a longer pierce, and we want to bring this back down to our standard piercing time. and go. Alright, we're not going to bore you with the whole run through here. Alright, we made a practice pass around, and it looks like everything's going to line up fine, and it looks like it didn't move. This thing, you know, this is a couple 100-pound piece of material anyway, and we're attempting. This is 1/2 inch stainless steel, 316 grade. We've drilled out our pierce points so we don't have to have the flashback and the fire. Fairly new contact, not a brand new one, but it is fairly new. And we're going to be traveling at 20 inches a minute, and we're going to give that an attempt. We can slow it down a little bit from there, but I believe that we were doing fine cutting 1/2 inch stainless steel at 20 inches per minute, 60 amps on the dial, which is top end of our thermodynamic Cutmaster 81, and let's give it a attempt. Definitely looks pretty good to me. If we have no stops in this whole thing, it takes 11 minutes and 40 or 50 seconds, I think. That's barely skimming across the back side there. In fact, I was worried about it actually coming down and touching, but it's holding enough. Just enough to put a new edge. We'll be looking at my edge and then their edge. We have that to compare with on the main cut of the machine here. see if we can pick these up here. This is actually sucked right back in on it. You can see that you can hardly pull that in there. I know once I get a screwdriver in there and get it pried up, I can. It actually just closes sideways in on it. See what I mean? You know, look how tight it makes that. And also too, we have a 10,000ths. Start and stop at the end here, so we don't over melt and create a groove in at our end of our cut there. That's why these are all held in there. See, they all just tilt because there's 10,000ths where it stops before it gets to the exact spot again. Same thing here. This one here, I might need to go get 2 screwdrivers because we're in both ways. Oh, maybe not. There we go. Real nice cut on it. Same thing there. Alright, we're going to let them cool down. Alright, we're going to be cutting out 8 shims to shim in to the positions if need be on the pads. Because they don't know if they're going to have to do some kind of alignment or leveling, so they're kind of going for that option there. So we're going to go ahead and cut them out some shims. This happens to be an 1/8 inch batch, and we're going to do 8 of them. We may do another 8. We want to kind of look at the combinations that we can play with there with the other. We're going to see how many quarters that we can get out. But we're going to go ahead and make this run on this 8 out of 1/8 inch steel. We increase the speed to 40 inches a minute. It may even be able to go up to 60 inches a minute. We want to take a look at the first one first and see how it goes. We're going to let it run. come out clean. Very little dross on the back. Pretty square on the edge. I put the radiuses on there so it'd be able to, you know, once I went around with a sanding wheel, you know, nobody's gonna get poked. All right, this is a piece of 1/4 inch now, and we're trying it at 30 inches a minute, 60 amps, and there'll be 8 of them, two beside each other for 4 long. Okay, we gotta stop for dinner. Okay, we just got done eating. We're getting fired back up. Alright, a little more ventilation. We got 3 more to cut out of this section here. And then we're gonna go ahead and we're gonna cut 8 more out of another piece here. Alright, let's go ahead and want to do our covers here. And you can see that really, this piece of stainless steel, I think we pretty well have used it up. We got a rudder out of it, we got a square plate out of there, and not much left. I think this is scrap now. Alright, and just take and throw these up on the table here. Actually, if they fall down in the water, they're usually a little safer than if they hang on the side there. Alright, we're gonna get those I think five out of here and one out of over here. So we're just adding, I mean, this plate is just a little small plate here. It's got a few areas left to cut on here. And we're gonna go ahead and we're gonna choke this up just a little bit here. There we go. Alright. Oh. That's why we had that over there. You can't choke up the area you're going to cut, right? Alright. We'll call that go. Alright. We're going to hit the collection of the 5 first. Want to get you in a little closer here because that was pretty cool. All right, here we go. Okay, cut. Alright, we're cleaning up our shims. The shims are going to be a assortment of shims is what we cut out, so that these stainless steel plates that they're going to add in on this project here underneath supports for a skimmer on a sewage treatment plant over a sewage tank. I'm glad I got this part of the job. Anyway, you saw me put these on a table, and basically I kind of interlock these things physically by putting them in, manually. And also one section there, I was able to go ahead and give it an array and then stretch them on out and then kind of like space those out. Those are a couple different ways of actually getting something laid out on the table. Now, I think tomorrow, possibly I should be receiving my nesting software for laying things out on a plate. I have a couple of jobs coming up, and I have a number of parts that I'll have to be cutting out, and we're going to give that nesting software a go, and I'll be showing you my take and how that's working out for me. Alright, back to cleaning up these. They don't get done by themselves. Oh. I do favor Norton disc here. If I tried several different kinds, the Raynors and a couple other. Yeah, they save you money, but do they? If you're going through twice as many, also they just hold up a lot better, and they hold that flatness to them. You get used to using them. I'm lucky that I have. I'm starting to control my dross a lot better. I'm getting a good feel of what tip, what speed, what amps, and all that comes into play about what's on the back side. Stainless is the hardest one to get adjusted and deal with. Alright, we'll just knock this one out here. We're going to knock these all out, and then we're going to get to dressing up these plates. But that one little area right there, and you can see that's the hole I drilled, how close I was able to locate where I wanted that pierce to start, come around. And, and also this hole right there is where that little contact area was, and how clean that hole actually is. Right? And, they're just popping out, just that little section. It's the only thing holding them. They're all the same, just that one little tab right there. That's solid. Hold them up. All right, I'd like to touch a little bit on drilling out the pierce points on this job here. 1/2 inch can cut real comfortable on my machine. I using about a 60 amp tip, and I'm cruising along at about 20 inches a minute, and I'm getting excellent side straightness, minimum dross, and real good performance out of the plasma torch on my plasma cam. And this job has come out really nice because I've taken the time to go ahead and drill those pierce points. Now, it can pierce 1/2 inch, but it has enormous amount of blowback and stainless blowing back. It's bad news on your gear, okay? So if we can keep all the debris and everything else going in one direction, it's why my machine stays clean and everything else also. But also, when you come around such a short distance, come back to the same hole, and you have no build up on the outside, your cuts finish off well enough where you saw that little tiny, I got it set for 10,000 stop before it gets to the end there, and these things were able to hang on right in there, and then we were able to knock them out with a hammer. And they broke off clean. Alright, so just want to touch bases on that, and here's a, before we go, here's a quickie photograph session of the edges and also the slugs that we cut out of the center here, and the quality of cut that was done on this job is best seen by standard photographs with my other camera, and I'll give you a good run on those. Alright, this is a wrap on this, and of course this is going down, and it's going to support a skimmer on a sewage treatment tank, and it's a contract where the whole facility is going to be rebuilt next year, and this was an emergency to get in there, and the skimmer fell off the side of the tank. Okay, so anyway, they're going to go put the skimmer back on, and at least I had the right part of this job. Get her done.